morning, everyone. In today's session, we'll be working on this DC motor. Okay, let's see like how we can control the DC motor using ESP32. Okay, in our ESP32 development kit, we have two MOSFET based driver circuit to control DC motor. Okay, we can control up to two different DC motors. Okay, and I will explain all the schematic diagram for this DC motor. Okay, it is a optocoupler and MOSFET based driver circuit. Okay, it like ESP32 will send only the logic and high and low signal to this optocoupler, and optocoupler's phototransistor it will control the gate terminal of the MOSFET, and by using this MOSFET we can control the DC motor. Okay, and in the second part will control the DC motor by using this Google Firebase. Okay, let's create one field to control the DC motor. By using that one, like if we set it as 1, the motor will be turned on, and if we set it as 0, the motor will be turned off. Like this we can control the DC motor from anywhere in the world. Okay, and like also explore like how we can design the Android application to control this DC motor. Okay, and in the same application let's also monitor this BMP180 sensor. Okay, that humidity altitude and temperatures data we can monitor using this application. Okay, and by using this application we can monitor and control the motor. Okay, yeah, and in the third session let's also see this ESP3266 12F development board. Okay, this is a new development kit using this ESP8266 12F. This is similar to the Node MCU. Okay, this board has relay OLED breakout and BMP180 DHT11 for temperature and humidity, and it also has like one MOSFET driver. You can connect single motor, single DC motor, and it also has 12-volt relays. Okay, two channel relay. You can control up to 220 voltage AC devices. Okay, to program this board we need separate FTDI programmer, that is USB to TTL converter. Okay, in this project let's control 12-volt geared DC motor of 10 RPM motor using ESP32. Okay, for that you cannot directly drive motor using the ESP32 GPIO because the power will not be the sufficient. For that we need to use another driver circuit to control the DC motor. Okay, in our development kit we have designed separate driver circuit by using optocoupler PC817 and MOSFET IRFR1205 TRP-BF. Okay, this is the MOSFET used to control the DC motor. Okay, because this only ESP32 it will give only the signal, that is on and off signal, but the power required by the DC motor is handled by the MOSFET based circuit. Okay, the MOSFET is a metal oxides field effect transistor, and one more component we have in this driver circuit, that is a optocoupler. Okay, and combination of these two can be used in conjunction to control a 12-volt geared DC motor with an ESP32 microcontroller. Okay, in this circuit, MOSFET acts as a switch to control the motor's power supply. Okay, we need to connect the motor's positive lead to 12-volt supply and negative lead to MOSFET's drain terminal. Okay, the ESP32 can control the MOSFET by applying a voltage to its gate terminal. When the gate voltage is applied, the MOSFET conducts, allowing the current to flow through the motor and making it spin. Okay, this is like if you want to directly control like MOSFET using the ESP32 GPIO pin without using optocoupler, we can directly connect GPIO to the MOSFET's gate terminal. But for the protection, for the additional protection, we will be using this IC, that is PC817. This supports galvanic isolation. Okay, this is an optocoupler used to provide electrical isolation between ESP32 and high voltage side, that is MOSFET and 12 voltage side. Okay, this helps protect the ESP32 from potential high voltage spikes or noise. Okay, connect the ESP32's GPIO to the optocoupler's input. Okay, this is the ESP32's GPIO. Okay, this net label is MOSFET 1. It is connected to the GPIO pin of the ESP32. Okay, yes, in our development kit we have two MOSFETs, right? Like two of these MOSFETs net label is connected to the D4 and D2 of the ESP32. Okay, this is the MOSFET 1. This is one driver. One more is this is MOSFET 2. Okay, we can connect up to 2 DC motors in our board. Okay, this ESP32 GPIO pin is connected to the PC817, that is optocoupler. Okay, and this is optional, like this LED and resistor which is connected to the ground, this is optional. This is just for an indication. Okay, if this pin goes high, the LED will be on. If this is off, LED will be off. Okay, in this circuit, like ESP32 GPIO, that is pin number 214, is connected to the optocoupler LED side. This is the LED. Okay, this is phototransistor. Okay, there will be a isolation between these two things. And this resistor is to protect this internal LED. Okay, I'm not using mouse. Without mouse it is difficult to control. That's okay. And the optocoupler's phototransistor side is connected to the gate of this MOSFET. Okay, and MOSFET drain is connected to the motor negative, and motor's positive is connected to the 12 volt. Okay, and connect the ground of the 12 volt supply with the ground of the ESP32. Create a common ground reference. Okay, and yes, this is the a simple circuit for this motor control using this MOSFET and PC817 optocoupler. Okay, let's go to the programming part of the project. Okay, in this project I will be controlling this ESP32 from this Google Firebase. Okay, like I will be continuing with the yesterday's Firebase project. that is zolcanautomation.firebaseio.com. Okay, and it will be connected to the same Wi-Fi network, that is Zolcano. Okay. In this project, like I will be monitoring uh, like this field in the Google Firebase, that is MOSFET. Okay, I will be setting it as 0 uh, at the beginning. Okay, when we set it as 1, that GPIO pin will be turned on. Okay, for that you can see here the fire status. If the fire status is 1, that is if the MOSFET status is set to 1, it will go inside this loop. Okay, when it goes inside the loop, the LCD will print as MOSFET on, and in second line it will print as MOSFET on for 5 seconds. Okay, in this I am setting GPIO2 as I. Okay, like one of the MOSFET will be on if we um, if we send MOSFET, if we set MOSFET as status as 1, it will come inside the loop, and like it will turn on the motor for the 5 seconds. After that it will turn off. Okay, and like after 5 seconds of motor spinning, it will turn off, and again that MOSFET status will be set as 0. Okay, like this we can control the DC motor using ESP32 development kit by using Google Firebase. Okay, in this example I will be controlling DC motor, and I will be monitoring temperature and altitude readings from BMP180 using this Android application. Okay, I will upload the screen recording of the Android application later, and but now I am showing this UI part of this Android application. It has two buttons, one is on and one is off, and in this fields it is like temperature data will be updated here, and altitude will be updated here. Okay, this is the simple application designed using MIT App Inventor. Okay, by using this MIT App Inventor, you can easily design the Android application for the basic IoT, like whatever the things you need. See, in this application I'm using this two buttons and two fields to read the temperature and the altitude. Okay, this is the UI part, and this is where you write this graphical programming. Okay, it is similar to the C programming. If you know the C programming, and then you can easily learn this thing. Okay, this is the Firebase get value, temperature and humidity, and this is to set the GPIO pin. Okay, whatever the data which we get from the ESP32, it will be updated in the um, text field, that is here. Okay, yeah, here it will be updated. Okay, you can generate the APK file, and you can share it with your friends also, so that anybody can control the device from anywhere in the world. Okay, now I will demonstrate like how we can control this LED field by using the Android application. I think the app will not be visible for you, but I will update the screen recordings later. But now I will show like how we can control the LED status, and this LED is connected to the um, like motor, like if we set this LED to 1, the ESP32 will control the motor. Okay, the motor will be on for the next 5 seconds. Now I am pressing that green button in the Android application, that is this button. I'm just clicking that button in my mobile phone. Okay, that if now I'm clicking, that LED status will be set as 1 and motor will be on. Okay, yes, the motor is on and LED is set to 1. Okay, and it will be turned off after 5 seconds. Okay, this is how we can control Google Firebase by using this Android application. Okay, thank you.
In this project, I will be controlling DC motor using ESP32 development kit. Okay, this is the 10 RPM geared DC motor which works at 12 voltage. Okay, it is connected to MOSFET based driver circuit. See, there is a two two MOSFET based development motor driver on this board, which is connected to GPIO 2 and 4. Our motor is connected to one of this driver. Okay, and now the board is connected to Google Firebase. From Google Firebase, I can control this motor anywhere in the world. Okay, see, this is the Google Firebase dashboard. In this, to control the motor, I need to set it as a 1. Okay, I am setting this as a 1. If that Firebase MOSFET field is set to 1, the ESP32 board will read that status and it will turn on the motor for 5 seconds. After that, it will turn off the motor and that state will be set it back to 0. Okay, I am setting it as 1 more time. See, motor will be on for 5 seconds and it will be set to 0. Okay, this is how we can control DC motor using ESP32 from the Firebase. Like that, you can control 2 motors in this board.
Okay, to send the BMP180 sensor temperature and altitude value to the Android applications which we have developed using MIT App Inventor. Now we need to send to the Firebase first, and from the Firebase we need to fetch using that Android application. Okay, for that these are the two fields, humidity and the temperature. But for this humidity, I am sending this altitude data. Okay, because this is the old applications which I have designed like almost 1 year back. Okay, I'm just sending this temperature and humidity like barometric sorry, BMP180 data to these two fields. Okay, the UI part, like I have added instead of this humidity, I have just added this altitude. Okay, to this altitude, like we are reading this altitude value from the sensor. Okay, for that we need to read the BMP180 sensor, and then to this field temperature and humidity, we need to update the temperature and altitude value. That's it. This is the floating point data. We are just updating the sensor readings to the humidity and the temperature field, and by using this Android application we can monitor the sensor data. Okay. These are the two fields. This is the altitude data, that is 879. This is the temperature. Okay, it will be updated every 5 seconds.
This is the demo of the ESP32 Firebase Android application. Here in this demo, we can able to monitor this temperature and altitude data. This app is directly connected to Google Firebase. Okay, and the ESP32 with this BMP180 sensor is sending data to the Firebase application, and we are able to fetch the sensor data wirelessly, and we can monitor this sensor readings from anywhere in the world. Okay, like this we can connect any sensor to the ESP32 and we can monitor using this Android application. Okay, and we also have this on off buttons to control the motor. Okay, green, if we press this green button, the motor will be on for 5 seconds and it will turn off automatically. That like turning off thing I have written, like if you want to continuously like on the motor, you can do that. And because like we have this off button, this if we press this off button, it will set the motor to the 0 state. Okay, with this application we can monitor and control the IoT development kit. Okay,
Till now, for all these projects, like connecting BMP 180 sensor to the uh, Google Firebase, ThinkSpeak, and controlling motors, and controlling the buzzer, like we have used ESP32 development kit. From now on, let's use this ESP8266 12F IoT development board. Okay, this is the similar board, but it doesn't have this Bluetooth feature. Okay, in these boards, it has this two relay to control the AC application. Okay, and it also has this 30 ampere MOSFET to drive the motors or any solenoid valve. Okay, and it also has this buzzer and OLED breakout. By using this board, we will be connecting this to OLED display, and it also has this BMP 180 breakout. You can directly connect BMP 180 sensor and DHT11 also. Okay, and to program this board we need FTDI programmer, and like you need to connect FTDI programmer to these pins, and you need to set it to the programming mode to upload the code. Okay, um, to program this board we will be using Arduino IDE only. Okay, and And now we'll see the schematic diagram of this development kit. Okay, this is the 3D diagram of the ESP8266 development kit. Okay, yeah. Mm. This board can be powered by using 12 volt DC adapter, or you can directly connect 12 volt uh, 12 volt transformer also, because this board has onboard bridge rectifier. This will convert AC to DC. Okay, it also has this filter capacitor, and the main regulator which we have used is 7805 voltage regulator. This will convert DC 12 voltage to the um, DC 5 volt. Okay, and this is the power LED. Okay, and once we get this 5 voltage, we are using one more LDO, that is AMS 1117 3.3 voltage. By using this LDO, we are converting 5 voltage to the 3.3 voltage, which is required for the ESP8266. Okay, and these are the power supply headers. Okay, 3.3 ground, 5 volt and 12 volt. Okay, coming to the circuit, this is the main Wi-Fi chip used in the development kit. This is ESP12F Wi-Fi module. Okay, and these are the pin connection. The buzzer is connected to the GPIO 12, and DHT11 is connected to GPIO 0. BMP180 is connected. This is the I2C best sensor. That's why it is connected to HDA and SCCL. That is I2C pins of the ESP module. Okay, and in this board, like, there are two buttons. One is to reset the module, and another is a general purpose button. This button is connected to the GPIO 13 of the ESP12F module, and we also have this UART header, I2C header. If you want to connect to any external I2C module, you can use this I2C header to connect to the module, external module. And this is the FTDI. To program this board, you need to use this FTDI serial to TTL converter module. And this is the OLED display. OLED also works on this I2C protocol. That's why it is connected to HDA and SCL. Okay, in this board, like, we have two I2C devices. One is BMP180 sensor, and another one is OLED display. Okay, and uh, these are the two relays. To relay. This relay connection is similar to that like MOSFET and optocoupler circuit. Okay, here optocoupler phototransistor is driving this transistor. This will like handle the on and off circuitry of this relay, external relay. By using this relay, we can connect 220 voltage AC application, or any high voltage DC application, DC device. Okay, these are the two relays used in this development kit. Okay, and let's see, like, in coming session, let's see how to like add the software development package on the yeah, Arduino IDE. Let's download the software. To download the Node MCU support package for the development board, go to this Google and search for the node MCU ESP8266 Arduino JSON. Okay, then copy this link. Okay, arduino.esp8266.com stable package underscore ESP8266 com underscore JSON index.json. Okay, then go to the Arduino IDE. Okay, in Arduino IDE, okay, go to this file and preferences. Okay, this is the link for the ESP8266. Type comma and then paste this ESP8266 link and then press OK. Okay, it will add this ESP8266 package URL, and then go to the board tools board and then boards manager. Okay, now type node MCU. Okay, now we got this ESP8266 by ESP8266 community. Okay, you press install. This will download all the support package which is required for the programming node MCU development board. Okay, now it is installing all these packages. Let's wait for some time. Yes, now it is completely installed. Okay, yes, this is the one more support package which we have added. Now we need to select this one, that is node MCU 1.0 for our development kit. Okay, now I have selected, and let's try compiling this Blink example code. Board is not connected to the computer, but I am simply compiling this example code. Okay, compilation done. Like everything is working fine. Now let's connect the ESP8266 development kit and upload the example code. Okay, this is the ESP8266 2 relay development kit. Okay, we'll see how we can program this board. Okay, this is the FTDI development kit, FTDI serial programmer. Okay, we need to insert this FTDI programmer onto this slot. Okay, I just added this FTDI serial to TTL converter to the ESP8266 development board, and this is the slide switch. Okay, by using this slide switch we can set the ESP8266 development kit to the programming mode or run mode. Okay, once we done with uploading, we can set it to run mode. Okay, now it is in the programming mode. I am resetting this board once. Okay, now it is ready to upload. Okay, let's see how we can upload the code onto this development board using the Arduino IDE. This is the basic example code. Okay,
to upload this board, go to this tools and select this COM port. COM port is already selected. It is connected to the COM12 and board is also selected, that is Node MCU 1.0. okay, now let's upload the code. The code is compiling now. Yes, it is writing. While writing, this blue LED flashes. Okay. Now it is downloading is completed. Let's switch it back to execution mode. Okay, now the blinking LED code is uploaded successfully. Okay, this is how we can program this ESP8266 development kit. Okay, and to upload to upload the another code, you need to slide back to this programming part and you need to press reset. Okay, now the board is ready to be uploaded.